How many are we? 1918. Okay. Today we'll be continue with our nonlinear functions, where we begin nonlinear functions, where we started with your quadratic functions, and we spoke about the properties of quadratic functions, where our objective was to calculate or compute your total revenue using quadratic equations, cost functions, and profit. So that's where we started. And today we are continuing with our nonlinear, but now we are focusing on our market equilibrium. Remember, we have done market equilibrium under linear, but now we are coming to nonlinear, but we are still discussing our nonlinear, but now it becomes nonlinear demand and supply functions, where we know that we have linear demand and supply that falls under linear method. Today we are under linear, but discussing the same topic, which is market equilibrium. The difference, if you look at this one and the previous one, there's not much difference. The the approach is still the same, where, under market equilibrium, under linear, that's where we take the equation of demand, which is PD, P subscript D, and that will be equal to or equating to.
Sorry,
maybe,
sir, are you sharing your screen? I don't see anything.
Not yet. I'm just discussing. Okay, wait me. I think it's better if I share. Okay. I was just recapping what we have done previously. Okay. I said the topic of the day is market.
Market equilibrium.
Yes, market equilibrium. And I said, if you remember under linear function, we discussed market equilibrium, where we're saying the likes of Q subscript B is equals to Q subscript S.
Sorry, sir, we still can't see your screen.
We can't see my screen?
No.
Okay, thank you. Is it fine now?
Yes, we can see.
Okay. So I was saying previously, if you remember, under unit 3, we discussed market equilibrium. That was under linear functions, where we came across where Q subscript D is equals to Q subscript S, and we had where P subscript D is equals to P subscript S. I believe you still remember this. So we are still going to continue with it, but now the difference, it will be under nonlinear functions. But the approach is still similar. The only difference is that now we're talking about quadratic equations, whereby previously we're talking about linear equations, which is your straight line. So, because these are still the same compared to the previous session, if you remember the previous session, we had equations like this, where we said T PR TQ. We are still going to apply that if we're interested to find the total revenue. And we are still having our TC, which is still the same from the previous session. But here, first thing that we are going to do under market equilibrium, our interest is to find the turning point. That is the most important thing. And 2, we have to do our discriminant. And 3, we have to come up with a vertical axis intercept. So the reason we do all these things that I've mentioned, which is turning point, discriminant, and vertical axis intercept. These 3 items that I've mentioned, they're going to help us in order to do our graph. So to do our graph, we'll be given 2 equations. We'll be given our quadratic demand and our quadratic supply. So from these 2 equations, our linear equations, we must be able to come up with this information that I've mentioned. For an example, if you're given an equation of P sub D equals to Q squared 10Q plus 25. So this first equation, this will be the demand. The demand nonlinear. Let me just call it nonlinear. Demand nonlinear. Then we are given the second one, which is PS, P subscript S, Q to the power 2 plus 6, Q plus 9. It means this one, it will be supply. Supply nonlinear quadratic function. So these are the 2 equations that are given to us. And I said, from each equation, we must be able to calculate our turning point. Turning point for each equation, from supply and from demand equation. So from there, we have to calculate our discriminant. If you remember under the properties of quadratic, there's a point where we spoke about discriminant, and we are saying discriminant is all the information that you find under our square root. And if you remember under our square root, we had b squared minus 4ac. So this is our discriminant. So we are going to use this information, our discriminant, so you can be able to explain to us about the roots of our x-axis. If you remember, we had 3 conditions where it's greater and where it's equals to and where it's less. I'm referring to our discriminant. Then we have our vertical axis. Most of the time, vertical axis, it's given depending on the equation. But if you remember the equations that we're dealing with, especially under total revenue in our previous lecture, most of our equations, you find that would have equation like this, where we say TR, after converting it, will have maybe AQ, for an example, minus maybe BQ squared. So this one you find we don't have our vertical axis intercept. But if you remember, there was an equation. Originally, we are saying the original equation is written like this, maybe TR equals to AX squared plus BX plus C. So this is our intercept. So going forward, we'll see, for an example, looking at the 2 given equations, we can see this time we are given our intercept, our C. We have our A here, we have our B, we have our C. So, like I said, the first thing that you have to do from the given information, we have to calculate our turning point of the demand and also of the supply. So we'll take the first equation of the demand, where we have P subscript D equals to Q squared minus 10Q plus 25. So we are saying the first thing, 1, turning point. And I believe you still remember the equation of turning point because we've used it so many times in our previous class, where we say Q, originally it used to be X, but in this case, in economic sense, we use Q, which is for quantity. Q equals to minus B into A. So here we're trying to find our turning point. So we look at the information. Remember, I said from this equation, it's like this. AX squared plus BX plus C. So, like I said, this is A, we have B, we have C. So looking at this equation, we are saying from the given equation, we have to take the value of A that represent, or rather, value of B that represent B in this equation. And we have to take the value of A from the given information, the given equation. So in this case, we'll say we have 1 here and we have minus 10 there. So what do we do now? We say, okay, equals to minus, open brackets. We have 10 here, but it's not 10, it's negative 10. Then we say negative 10, close bracket, divide by 2. Like I said, if we don't have a number in front of a Q, we know that automatically we have 1 there. So there is our 1. So we multiply, as we multiply here, they will cancel each other. We have 10 divided by 2. Then our answer is 5. So we have 5 there as our turning point from the Q side. Sorry. Then we go now, let's talk about 2D, which is yes. So, like I said, this one where we're going to use what is within our square root. If you remember the quadratic formula under the properties. So that part, that's B squared minus A times C. So this is the part that we're going to use as our discriminant. So what do we do again? We refer back to our equation, the given equation. So we are trying to feed our equation based on the symbols that we have. So we can see that our B there is negative 10. And we say, okay, negative 10 squared minus 4, open brackets there. We have our 1 that representing our A there. Then we have our C, which is our intercept there, which is 25. Then we simplify our problem. Then that's where you'd say we have 100 there minus 4 times 1 is 4, 4 times 25 is 100. Then we have 0. So our discriminant there at 0. So we know based on the properties of our discriminant that if it's 0, it means it touches the x-axis. That's the condition. Then the last one, anyway, this one is given to us. Vertical axis intercept. Vertical axis intercept is denoted by C from the quadratic equation. So it's in this case, we look at our C in our given equation, and we can see our C in our given equation is 25. So we know that, okay, our P there will be 25. So this is the demand, this is the quadratic demand function. So we go to the next one now, which is our supply. Our supply function, where we are given P as the same procedure. We follow the same procedure. Still, we want our turning point. For our turning point, we're still going to say Q there equals to negative B divided by 2A, where we have negative 6. Remember, this is A, B, C. Then we have our denominator, which is 2 times 1, because we don't have any number in front of Q squared that's representing A. So we simplify it. As we simplify it, we ended up having 6 divided by 2. I'm repeating it. Then we have negative 3. So this is our turning point. Then we want our discriminant. Formula for discriminant, we said, is B squared minus 4AC. Therefore, we subtract our information, B squared there at 6 squared minus 4, H still 1, and our C in this case is 9. Then we have 36 there, minus, we say 4 times 1 times 9, also 36. So you can see also it touches both x's, where our answer is at 0.
Sorry, sir.
Yes, ma'am.
I've just got a question, please. Just
Okay.
go slightly up to calculation of the discriminant for
Which one? The one of demand.
Yes, for demand. Why do you
Okay.
have, okay, if you have minus 10 squared, why did you say it equals, it's a positive 100 and not negative 100?
Can be, it's squared. If you square
So
that,
just
it's like
to-
you say
always
times
a positive.
times that, yes.
Okay, perfect. Thank you.
Okay. Okay. So now we are done. So what do we do now? We want to equate our equations, to equal our equation, where, if you remember, under equilibrium, I mentioned earlier on, where I said under linear function, this is what we discussed. So for us to find that intercept point where these two graphs, they intersect. So in this case, because our equation is P subscript D equals to Q squared minus 10Q plus 25. This is the first equation. First equation. Second equation is PS equals to Q squared plus 6Q plus 9. Then we say P, to find that equilibrium point, we say P subscript D equals to P subscript S. So we know P subscript D represent the first equation, P subscript S represent the second equation. So we say, okay, let's take our equation, Q squared minus 10Q plus 25Q equals to Q plus 6Q there plus 9. So now we have to now group the like terms. So when you group the like terms, let's take our Q and Q6, Q squared and Q and 6Q to the left-hand side. Then we'll take 25 to the right-hand side. Then we have Q squared minus q squared. I'll try to bring them together closer. Q squared minus 10q minus 6q equals to 9 minus 20, 25. So if you look at this q, this one is positive, this one is negative. So it means they will cancel each other. This becomes 0. So here we ended up having negative 16q equals to. So the other side, if we subtract here, we ended up having negative 16. So we're interested to find q. So it means we're going to divide both sides by negative 16. That goes that, and that will cancel each other. Then we ended up having q equals to 1. So our q there is equals to 1. But now we are not done. What we're going to do, because now we said these two equations are equal. So it's up to you guys. You can take this one and try it. I will try to take the first equation of demand, where q is equals to, just to check, are we going to get the same value? Q squared minus 10 q plus 25 equals to, let's say, equals to p. So what do you want to see? Oh, subscript d. We said q is equals to 1 when we're making equilibrium, calculating our equilibrium value for q. So what do we do now? We take this 1 and we subtract that 1 from this equation. And you can also try the second equation. And what is important, they have to give us the same value. If we subtract here and we ended up getting 10, so it means the second equation of supply function, it also has to give us 10. Then we are saying these two equations are equal. So we say, okay, 1 squared plus 10 open 1 plus 25 equals to, or let me just put it this side. Subscript d. Okay. Then here we have 1, we have 10, we have plus 25. Then here we have 9, negative 9, and negative 9 plus 25, we have 16. Are we together, guys?
Yes, sir.
Okay. So this is for demand. You can also do the same for supply. Okay, let's try supply. Let's try the equation of supply. The equation of supply, we have we have P subscript as there equals to Q squared plus 6Q plus 9. Okay. So we do the same. We're going to take the very same one and we subtract it from the equation. Then we have 1 there, plus 6, plus 9. Then we have 16. So we have 16 and 16. So it means you can say P subscript D is equals to P subscript S. Okay. So let's try to do our design of mine is not according to scale. this side, we can say we have, let's have 10. 20. Okay. So if you remember, we had two intercept, the intercept of the first equation, which is 25. Probably it will be somewhere here. And we have the second one, which is 9. It's somewhere here. And okay. Somewhere here we have just about 10 close to 20. That's where we'll have maybe our 16 there. 16. So we'll have our line, broken line there. That shows our equilibrium point. This is here. So it means this one, the graph goes this way. Oh. Then we'll have, because it started from our intercept. Then we have another one there of the intercept of 25 that goes down. Yeah. So it means this is the point that we were calculating. Where we know there, we have Q, we have 16. So that is our equilibrium point, where we know for our supply there, we have P subscript S there equals to Q squared plus 6Q plus 9. And this one we have P subscript D equals to Q squared plus, or rather minus 10 Q plus 25. That's our quadratic demand and supply function. Questions? Questions?
Hi, so I've just got a question.
Yes.
Okay, I'm just plotting the graph.
Okay.
The one that's 25, Y is 20, sorry, P is 25 and Y is 5. Okay, just hold on. Okay, 25 and 5. So the turning point is 5, so it ends there on 5.
Yes.
And the
yes.
vertical axis is 25, so that's fine. But the turning point is -3. -3 on the Y-axis. Is that right? No.
Yes, so it means if
9
we
on the
had
X.
to do it, it means it was going to pass like this. You see that?
Yes, perfect.
But remember, we're only interested on the first quadrant for now. So
Yes.
it means it was going to pass like this, and we have that -3 on the x-axis, but on the negative side.
Okay, and then it goes up to 9. 9 on the vertical intercepts. I just don't understand that. I'm just trying to look at it here. Just hold on. Okay, -3 crossing over to 9 there. Okay, perfect. Thank you. I understand.
Yes. Okay. Questions? No questions.
No.
Okay. If we don't have questions, let's go to the next topic, which is our break. What is break-even point? What do you understand by the word break-even point?
That's where the total revenue equals your total cost.
Correct. Thank you. Okay, so we are going to do that. Now we are going to see how do we compute or calculate our break-even point. So it means for us to calculate the break-even point, we'll have to talk about your total revenue, your total cost. But already we've passed here where we discussed the total cost and the total revenue. But if you remember in the previous lecture, we were calculating the TR and the TS with the objective of getting our profit. So now we are calculating, and we are saying like you were saying that total breaking point is where the total cost maybe is equals to total cost. So already we know how to compute the total cost, and we know how to calculate the total cost. But furthermore, it says if total cost is equals to total revenue is equals to total cost, that means your fixed cost plus your variable cost. So it means variable cost, fixed cost plus variable cost is equals to total cost. So now we are going to include this two for us to calculate our total cost. So now we can be able to say, okay, we have a breaking even point where we say total revenue is equals to total cost. What makes total cost? Total cost is made by total fixed cost plus variable cost, where we know that TR is equals to P times Q from the previous lecture. Okay. So if you look at from our study guide, we're given an example there where they say, example says, a company produces a product at fixed cost of 30 Rand and variable cost of 2 Rand per unit. The demand function for the product is given as Q equals to 65 minus 5P, where Q is the number of units produced and sold, and P is the price per unit. From the given information, now we have to calculate our total cost and now be able to come up with our equation. So first thing that we have to get from the given information. So we have to gather that from the given information to say, okay, like I said earlier, I said to you, fixed cost plus variable cost is equals to total cost. So I'll repeat that. Total cost is equals to fixed cost plus variable cost. So from the given information, it shows that, okay, our fixed cost there is that rent plus our variable cost there is 2Q. This is our total cost function. And furthermore, we are given the demand function of Q equals to 65 minus 5P. And you remember, if we are given the demand function of this nature, demand function, we can be able to derive our total cost given the function of demand. If you remember, we have done that in our previous class, where we wanted to have the equation of total revenue. And if you remember, we said that total revenue is equals to P times Q. So where we know that P is equals to price per unit and Q is the number of units produced and sold. So we are given our function here, our demand function.
Sorry, sir.
Yes, ma'am.
On the total cost, You said it's 30 plus 2Q.
Yes.
I don't
Yes.
understand that part. Why 2Q, not 2? Because the variable cost is 2 per unit. Okay, thank you.
You just said it.
Okay, I see. Thanks.
Okay. Okay, thank you. Okay, now this is what we have. So we know that it's possible for us to derive a total cost equation or function given a demand function equation or function. So where we know, okay, TR is equals to P times Q. So looking at the given function, the demand function, we can take that and substitute where we see Q in this case. So check something quickly. The term we need to find out when you is Q. We have function Q, blah, 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 blah. So it means the interest here is to find Q. Because if you look at the function of total cost, it's made up of 30 plus 2Q. So it means in this case, if we can continue, just an example, if we continue, maybe I'm looking at this function, we say, okay, where we see Q, we put this function. It means we ended up having P open brackets 60, 65, P close brackets, and we ended up having 65P minus 5P 5P squared. But look at the equation up there of total cost. We have Q. So it means from this, our interest is to find Q. So we are not going to calculate here to derive the equation to have P. So we have to have similar equations because now remember our interest is to find the break-even point. But now if you look at here P and here Q, so it means it won't be possible. So it means what you're supposed to do in this case, I'll erase this. Let's look at the equation. This is the demand equation. So it means what we're going to do here, because of our interest, is to calculate for Q. That we can say somehow it was directed by what we have here up there on the total cost. So it means what we're going to do before we can derive this equation. Now we have to deal with the demand function equation, where now we are saying, okay, let's take 65. If we take 65 to the right-hand side, we ended up having 5P. I hope it makes sense. Negative 5P plus Q minus 65. So we want to get rid of that, then to have P. So if we want to have P, we ended up having P there equals 2. Then we divide. It's the same. Remember, we still have 1 here. It's the same as we say 1 divided by 5. Then we ended up having negative 0.2Q plus 65 divided by 5. Then we have 30. Do you follow, guys? Hello?
Yeah.
Okay, thank you.
Yes, we follow.
Okay, so now we can go back to our total revenue where he said it's equals to P times Q. So we say, okay, where we see P in this equation, we can now put what we have on the right-hand side, which is negative 2, open bracket, negative 2, negative 0.2 Q plus 13, close brackets, times our Q there. Then we ended up having negative 0.2 Q squared plus 13Q. So this is our equation for total revenue. So we have two equations now. We have equation of total revenue and we have equation for total cost. And now we are saying total revenue is equals to total cost, where total revenue is negative 0.2 Q squared plus 13Q equals to 30 plus 2Q. So what do we do now? Let's group the like terms. We have negative 0.2 squared, Q squared there. If we take this 2 to the left-hand side, we ended up having plus 11Q minus 30 there equals to 0. So this is our function. But we're not done. We have to find our values. So where we know that we have, if you look at this now, this is our quadratic equation where we have our A and our B and our C there. So now we want to find the two values that will represent our Q in our Cartesian plane. So if it's possible to factorize this, we can factorize it, or you can use our equation of X equals to minus B X equals to minus B plus or minus open brackets plus or minus square root our discriminant there divided by 2A. So you can just plug all this information that you have in this equation and substitute here. So we can have our two values. So meaning what we're going to do, we say, okay, here we have negative 11 plus or minus open brackets 11 again. Oh, okay, yeah, 11 to the power 2 minus 4. We have negative there, 0.2 close brackets times our intercept there, it's negative 30 close the brackets. Then we have 2 times negative 0.2 . So we have to simplify it. If you look at negative 11, it's not going to change. You can just leave it there. Let's try to simplify what we have in the bracket. So we say 11 squared there. Then we have inside there 121 minus, then we say negative 4 times negative 0.2 close brackets times negative 30, not 3, negative 30 close brackets. Then we have negative 24. So below there, just multiply what we have, which is 2 times negative 0.2. Then we have negative 0.4. Let's leave 11 for now and try to simplify what we have. 121 minus 24, we have 97. Divide by negative 0.4. So it means now we are going to have negative 11, let's say minus, it's up to you. You can start with minus or positive, it's up to you. Or you can say positive, then 97 there, divide by negative 0.4, or, because remember we had plus or minus, plus or minus. So in the case of plus, this is what we have. Now in the case of minus, we have negative 11 there again, minus open square root 97 divided by negative 0.4. So remember, we want our Q values. So we say negative 11 plus square root 97 divide by negative 0.4. Then we have 2.89. If we want to have one value, you can say after comma, you can say this is 2.9. Then or same thing. But now we have negative sign instead of positive. Then we divide that by the same value, which is negative 0.4. Then we have 52.1. So these are the two values of our X. Not X, Q. So from here, so you must be able to sketch our graph, because now we have the information that we need. Questions? Questions?
Sir,
Yes, ma'am.
do we still have to calculate the turning point, discriminant, and the vertical intercept as well?
Yes, because now you can see there's a turning point up there. So can you give us our value of our turning point? And I'm also interested to, if you look at your graph, I don't know, if you opened your study guide, I want you guys to give me the value where the first intercept, there's a first point intercept down there below 50. You see there? Guys?
Yes, sir.
Yes, I want you guys to give me the coordinates of the point, that intercept there, of the total cost. I want the values for that. We can see that our intercept there is 30. Our intercept is 30 and it's passing through our parabola equation. So I want you guys to give me the values that intersect at that point.
Okay, I've got 32.5.
Pardon?
I've got 32.5.
32.5.
But I'm not sure if it's right. Okay, I think it's incorrect because I did the minus b over 2a.
32.5. Let's see, because the intercept there it's 30. What is the value of X? Rather, Q.
Okay, I took q as minus 0.2. No, sorry. Okay, I'm just checking. It is the correct one that I'm looking at. Yeah. Hi, sir. I'm not sure if you're speaking. You're probably on mute because we can't hear anything.
No, I'm not speaking. I'm listening. I'm listening. I'm not on mute. I'm listening. You take your 2.9. We have two values. If you take your 2.9, going to give you a value somewhere there. And you substitute your 2.9 from the total revenue equation. Let's see. Guys, we have two values. We have the value of 2.9 and we have the value of 52.1. If we substitute those two values from our total revenue, we're going to get the right values. Do you follow?
Isn't it 36.0? I think I found
Yes.
36.0.
Yeah, that is 6.0. The other one,
I'm not sure,
Oh,
Doctor. I think the other one is 1.4.
134.4.
4. Let's see what I have here. Here it's 65. I have 65. Why are you having 134? Let's see.
Sir, sorry, sir, please can we work it out all together? Can you show us on screen?
Okay. Yeah. First one we said, okay, we have 2.9 as our Q. So total revenue there is equals to negative 0.2 squared plus 13. Then we put open brackets 2.9 squared plus 13 times 2.9. Then we have 0.2 there, open brackets, 2.9 close brackets to power 2 plus 13 open brackets, 2.9 close brackets. What did I do? The 2.9. Let me see inside. Or negative. Forgot to put negative. Okay, we have 36. Did you get 36?
Yes, I got 36.
Okay. We have 36. So it means 36 is for total revenue. Then let's go to 50. Negative 0.2 open brackets. 52. Let's say it's 52.1 close brackets. Squared plus 18 open brackets. 52.1. Now let me check What did I do? Q squared, blah, blah, blah. It's 10, Q 65. Let me check something. Because if you look at our Cartesian plane, it's not supposed to be far. Let me check something. Just quickly, just to verify, are we using the right? Open brackets. 52.1 close brackets plus 11. This pen. Just a minute. I want to check something. .9 close brackets or 2 plus 7 open brackets when it's plus minus 80. Something doesn't make sense. Here we have our 36.01. Okay. That's strange. Because now, like we did, if we get 36, we're supposed to have the same day. Let me check something quickly. Okay. 0 point u squared equals to 30. Okay, let's go a bit back. Okay, let's do our graph quickly. I want to check something. We have Q this side, and we have T, R, and we have T, C. Okay. I want to check something. Let's start with the graph of TR. TR is equals to negative 0.2 Q squared plus 13Q. Okay. For us to come up with our graph, okay, we say, let's equate this to 0. If we equate this to 0, we ended up having negative 0.2 squared plus 13q equals to 0. So what we are going to do from here for us to do our graph, let's say, okay, we have q there, which is common. Let's take out q. If we take out q, we ended up having q. Rather, we ended up having negative 2.0 q plus 13 equals to 0. So automatically, if we are simplifying this, remember we are simplifying this with an objective of having a value that will represent our q. We'll come back to the values of q that we calculated. Then we ended up having this one, because of its out, automatically it becomes 0. Then q is equals to 0. So now we are left with this part, which is negative 0.2 q plus 13 equals to 0. So we're interested to have another value of q. So for us to do that, it means we'll take this 13 to the right-hand side. We ended up having negative q squared equals to 13. Then what do we do now? We simplify this by dividing by negative 0.2. Then we ended up having q there equals to 65. So we have 0 here. We have 65 here. So it means our graph, as it goes, this is how it passes through. It passes 0 and 65. That is our first graph of total revenue. Questions? Questions? Guys, are you with me?
Yes, I will.
Okay.
No questions, sir.
You understood what I was explaining?
Yes, so far.
Okay, others, are you fine?
Maybe it's me. I struggled with that Q becoming 0. Maybe if you can explain that.
Okay, we are saying we want to have the values of q that are going to represent q in this Cartesian plane. If you look at our equation, it's our quadratic equation, but it doesn't have our intercept. So it means we can't factorize it like we normally do. I don't know you understand. Okay, let's try this. Maybe
I'm with
that will
you
make
there.
sense. Okay, let me try this to see that you'll understand why are we having 0. I will try this. Let's take, because we're saying we want to q, let's try this formula and see. Negative b there, plus or minus b squared minus 4ac. Just to see, cannot maybe simplify our problem. We are saying our equation there is negative. So it means this is our equation. Let me put our equation here. Our equation is TR equals to negative 0.2 squared plus 13q, right? And if you look at this equation, we can say we have A, B, but we don't have C, because C, we are saying C is our intercept, but it's fine. Let's continue. So we say, okay, now where is B? We have B as 13, negative 13, plus or minus, open brackets. B again, 13 squared minus 4 We have our A there, which is negative 0.2, close brackets. We have C, which is 0 in this case. Then we have 2 times below there, we have negative 0.2. Then we go down. We still have negative 13 plus or minus. Let's see, this one is going to fall off because of the 0 there. Then we ended up having 13 squared. So inside we have 169 divided by let me just simplify that, 2, where we have 2 times negative 0.2, we have negative 0.4. Okay. So it means now we're going to have, remember, we are calculating Q. We're going to have Q of negative 13 plus, open brackets, 169 divided by negative 0.4, or we have again negative 13 minus, open brackets, 169 may divide by negative 0.4. So it means we're going to have 2 values of Q. So let's see what we have. So if we try to remove the square root, we ended up having negative 13 plus 13 divided by negative 0.4. That's the first one. The second one, we have negative 13 there, minus negative 13 divided by negative 0.4. So if you look at our numerator, already we get 0 there. You see that?
Yes, sir.
So this side we have 26. Negative 26 minus 0.4. So here you can see for Q, we have 0. So we have 26 there divided by 0.4. Then we have 65. Are you fine now?
Yes.
I am with you now.
Okay. But this one is a long method. Do you see that? As compared to what we have done here.
Yeah, the short method was a bit tricky there.
Okay. Okay. So now we know that we can be able to do what you're supposed to do. So if we're interested, we can find our turning point. And I believe you know how to find your turning point. Let's see what's going to be our turning point. Given the information. Q there is equals to minus B divided by 2A. Our B is negative 13 divided by 2 times negative 0.2. What is the correct answer? Because we have negative 13 there divided by negative 0.4. What is our turning point?
Sorry, sir, please confirm where you've got minus 13 from, because I see it as minus 11. If you look
Minus
at
11.
PR.
Let's go up and see. This is 13.
Oh, you're looking at just hold on. Oh, you're looking
Total
at
revenue
the
function.
total,
Yes.
okay, the total revenue function. Okay, thanks.
Okay. So we have 32.
32.5.
Yes. So we go to our equation. So that tells us maybe here it will be our 32.5. Okay. So now you know that if you have this value, you can take that value and substitute it from the function itself. It will give you the value for our TR. So we know our TR is negative 0.2 Q squared minus 13Q. What is the value? Guys, I'm waiting for the correct answer.
Six, 3,
633. 633. I got
I'm getting 211.
I got 211,
11.2.
25. That's what you got.
Yes.
Okay. So it means we know that even looking at the values there, I think it's confusing that yes, here is supposed to be 211 because you can see our graph is just above 200. So you can see that we have our 32.5 there. Okay, there you go. So we have another line of our total cost. If you look at your total cost, you have an intercept of 30. So if you have an intercept of 30, that tells you that your graph is going to start from there. Because now if we decide to say, okay, we want the values of Q and total revenue, you can see that, okay, in that case, our TC is 30. You can say 30 somewhere here. So you know that just goes straight. So you guys must find the values of these 2 points. So that will be our total revenue there equals to negative 0.2 Q squared plus 13.13Q. That is our equation. The second equation here, which is our straight line, is your total cost equals to 2Q plus 30Q. There is our 2 equations. Questions?
I have a question. I wanted to ask, come the
Yes.
examination, will we be required to draw the graph?
I think your questions is MCQ questions. I think we'll be required to maybe given a graph. Maybe the question will be given a graph and you just, for an example, if you see this graph, they're intersecting somewhere, or we can say, okay, looking at the graph, this I'm looking at the quadratic equation, the demand one. If you look at the demand one, not the demand, rather the total revenue, maybe we can be given an equation where there's a graph of total revenue and you're supposed to find maybe the turning point, you see. Hello? Hello? Hello?
Mute.
Hello? Hello?
Hello, we can hear
Yes, sir,
you.
we are here. Yes.
Yes, I was saying maybe the question can be you are given a graph like this one, and the question says, okay, calculate the turning point of the total revenue function. So given the equation, I think you know what to do. Or maybe find the values of Q of the total revenue. So you know what to do, given the graph and the information like this, where you are given the equation, which is total revenue equals to negative 0.2 Q squared plus 13 Q. So I believe now you can be able to calculate that. And I don't think your exam will be different to your assignment. If you look at your assignment, somehow is your exam. The structure is the same. Questions? We are left with 13 minutes. Questions? No questions.
I have a question. I wanted to ask, assuming that our next class is on a Monday, so I wanted to know what we will be covering on a Monday.
Monday we'll be doing, let's see, because these examples, they take long. I was hoping Monday will be the last class, but I hope we'll do the last class because Monday we'll be doing, I don't think it will take our time. We'll be doing cubic function, which is the continuation of this, but I don't think it will take long. Then after that, we're doing our exponential and logarithms function. Yes, and limited growth. Yes.
Sorry, sir.
Yes, ma'am.
Would you be able to also include the activity after, well, actually, before cubic functions? The activity is in for the break-even analysis. See, I've actually gone through 1, 2, 3, and 4, and I've tied it up with the solutions in the back, but it's a bit difficult. So if you could please go through that, it would really be appreciated.
Okay.
Page 48, if you can.
Because of time, I think, but no, I'm willing to help you because of time, the interest of time. What you can do, maybe you can email me your solutions, and I'll look at them. Maybe just next to your solutions, I'll just do the write-ups and send it back to you. And if
Okay.
you still need more meetings, yes, we can maybe have a Zoom session around that.
Yes, it will be greatly appreciated because these solutions are very straightforward. It doesn't give us the details.
Okay.
Okay, yeah, thanks.
Maybe what you can do, just email it to me when you are done. You can just maybe you scan your solution and send it to me, then I'll look into it. Then I'll send it back. If you still want more explanation, yes, we can arrange to have maybe a Zoom meeting just to discuss it.
Thank you.
Okay. Questions before we close our session?
I have a question. I wanted to ask with regards to assignment 3. I saw under the discussion forum there, I think, where you have pointed out that there are errors in the question. So I wanted to ask that, if I'm not mistaken, I think it has like 14 questions. Are you going to reduce the questions due to the errors that are in some of the question, or what exactly?
I didn't see it, but I think what you can do, because I'm working with my colleague here, which is the primary lecturer. I think she's the one who's going.
Already, it's fixed. The
Oh, it's
errors.
fixed.
Yeah.
Okay, thank you. It's fixed. Questions?
Yes, my question is, are we allowed to send you the questions based on the assignment? Let's say maybe assignment 1 since it's closed already.
Come again? I missed something there.
I have something I didn't get right.
Oh, assignment. Which assignment? Assignment 1, for example, assignment 1.
Assignment 1, yes. Because
Okay.
there's something I didn't get right. Can I send you are we allowed to send you the question for that or my solution?
Yes, we can look it together if you don't mind. Yes, you can send it to me, then I'll look
Yeah.
into it. Then I'll give you the correct answer.
Okay.
Okay.
If I may ask, are we going to get a tutorial letter with solutions to maybe assessment 1?
Let me not answer that now. I think I'll give you an answer Monday. Just remind me on Monday, but I'll have your answer on Monday. That you're going to get the answers for the old assignments or not.
I'm on the same boat as the previous lady. Yeah.
Okay. No, I'll give you an answer, the correct answer on Monday when we meet.
Okay.
Okay. If we don't have questions, let's have a great evening. We'll meet on Monday.
Thank you.
Thank you. Bye.